loops, especially, are probably the one of the most core aspects of programming. Loops essentially are blocks of code that we can reuse over and over again, or at least they're pieces of code that allow us to do the same thing many times. And if you think about what computers and what programming is especially good for, is actually executing a very precise set of commands over and over again. When we think about a loop, really, the two biggest things that we need to figure out are, when do we stop and what do we do? And so today we're going to talk about two types of loops, as well as a break and continue keywords, which give us a little bit more control over how to modify and manage the life cycle of a loop. And then we'll also do a little bit on debugging as well. We won't talk about too much about debugging because it's more of it's a skill in of itself, but I would say it's more of an art than a science. So we're just going to give you some quick overview tips on debugging, especially in the context of these workshops. But just know that that will definitely be kind of a core work in progress for the rest of this curriculum. Okay, so diving right into it, what are loops? Loops are code that basically runs over and over and over again. And all loops have a condition on which they either start, or sorry, all of them have a condition on which they start, and all of them should have a condition on which they stop. So the first loop we'll take a look at is called the while loop, and the while loop requires three elements. There's the while keyword, and keyword, when we say keyword in JavaScript, that means something very specific. You might also have heard these things being called reserved keywords or reserved words. What that means is that these words are actually part of the actual JavaScript language. So if you, in most code editors or code environments, if you type in while, it will show up as a different color than the rest of the code. And that's basically because while is a part of the JavaScript language itself, right? So whenever you type while, it means something very specific. It's the reason why you can't have a variable called while, because while already means something else in JavaScript. So whenever you want to create a while loop, you need to use the while keyword. You then you include a conditional expression that evaluates to a Boolean. Basically, that's a very long and complex way of saying you need something that's going to either be a true or a false, a go or a no go. And I'll talk about why that's so important in just a little bit. And then lastly, we'll need a block of code. We'll need the actual thing that you want to execute, assuming you want to go with the go scenario. So, yep. So, and basically the way that the while loop is going to work is the block of code in the while loop will run over and over and over and over as long as the conditional expression evaluates to true, or let me paraphrase that, the block of code will run as long as the conditional expression's a go. As in, it says, hey, you're fine to keep running this, to run this code again and again. So if we take a look at a real while loop, it might be a lot easier to understand what that means. So on line 1 here, we've created a variable called count, and we gave it the initial value of 3. On line 3 then, we decided to create a while loop. Notice how the first thing we do on line 3 is we have our while keyword, so that tells JavaScript that this is going to be a while loop. And then we have a bunch of code in between the parentheses, right? So the parentheses after the while loop are very important, because basically between the parentheses, what you're going to have is an expression or a snippet of code. And what JavaScript is going to try to do is it's going to take a look at the code in between the parentheses, and it's going to say, is that statement in between those parentheses, is that statement true or is that statement false? If the statement is true, then it means we run the block of code. If it's false, it means we don't run the block of code and our while loop is over. And so here, on line 1, we create a variable called count. We set it equal to 3. On line 3, we have our while keyword, and then we have our check. Our check basically says count is greater than or equal to 1, right? So the value of count is 3, and so the statement inside the parentheses basically boils down to, is 3 bigger than or equal to 1? And the answer is, that's a true statement, right? It's true because 3 is greater than 1, and therefore whatever statement is inside that parentheses is going to be true. And because that statement is true, we then execute the block of code in between the open and closed parentheses, right? The open parentheses on line 3 opens our block of code, and the closed parentheses on line 6 closes our block of code. And so when JavaScript encounters this code, the first thing it does is it gets to line 1 and makes a variable called count and gives it the initial value of 3. The next thing it does is it goes to line 3. It says, okay, great, now I'm dealing with a while loop. the first check to say is the variable count greater than or equal to 1? And the answer is yes, which in this case it is. We then move to line 4 and 5. We run line 4 and we say count is. We print out count is, and we print out the numerical value of count. And then on line 5, we do count minus minus, which means subtract 1 from the variable count. At this point in time, the loop then takes us back to line 3, right? Because basically what we said is you're free to run this loop once, and then we ran it once. And now we need to check the while loop again and see, do we need to run it again? Except this time when we check line 3, we're still checking whether or not the variable count is greater than or equal to 1. But now the value of count is no longer 3, it's 2, right? Because on the previous run on line 5 there, we subtracted 1 from count. So now count is 2, and then on line 3 we check, is 2 greater than or equal to 1? And the answer is yeah, it's still a true statement because 2 is greater than 1. So then we run the block of code again. We run line 4 and we print out count is 2. And then we run line 5 again. And we do count minus minus. So we subtract 1 from count. So now count is now equal to 1. We then go back to line 3 and we check again. Is the value of count greater than or equal to 1? And the answer is yes, that's still true. Count is 1 and 1 is equal to 1. So then we go to line 4, we console log out count is 1. On line 5, we do count minus minus, so we subtract 1 from 1, so that gives us count is 0. And now we go back to line 3 and we check again. And we say now is count greater than or equal to 1? Well, the value of count is now 0. And so 0 is not greater than 1, and it's also not equal to 1. And so because the expression in between our parentheses on line 3 there is finally false, that means our loop is finished running. And therefore we can move on to line 7, 8, 9 of the code. And as a result of running this loop, we've printed out count is 3, count is 2, count is 1, and then after count is 1, we go to line 5, we do count minus minus, so 1 becomes 0, and then we say, hey, our loop is now finished. I know that was a bit verbose, but do folks have any questions on how that loop just ran? Everyone good? Cool. And so when we think about a while loop then, right? You can kind of tell the parentheses, like whatever statement is in between the parentheses, we call it the conditional. That becomes really important because that essentially is our green light, red light, right? That tells us, should we run the next iteration of the loop or should we not? And so here in this case, I have a while loop, right? Because I have a while keyword. In between the parentheses, I just have a false value. And then for the block of code, I console log out this line of code will never run. And why do I do that? Now when JavaScript executes this block of code or this snippet of code, it goes to line 1 and says, okay, great, now I'm looking at a while loop. It goes into the parentheses and says, okay, great, is this statement in between these parentheses, is that true or false? And it's false. And so at that point, JavaScript just says, hey, great, the conditional expression is now false. That means I'm done with this loop, and I move on to the next block of code. So I move on to line 4, 5, and 6. And so in this case, even though we made a while loop, because the conditional statement's initial value was false, the block of code on line 2 never runs. And so it's very possible for us to create a while loop that theoretically never executes a single time. The flip side of this will be then, what if we have something like this now? We have a while statement, and our conditional expression is true, and in fact, it will always be true, right? Because we never change the value. Well, when you try running this line of code, or this block of code, when the computer sees a while keyword, it will then check the conditional, which will be true, and so it'll console log out, this line will run forever. Then it will move back to line 1 and says, great, should I do it again? Well, what's the conditional value? The conditional value in between the parentheses is still true, so it will console log out, this line will run forever again. And then it will check again line 1, it will see it's true, it will run line 2 again, and this basically goes on indefinitely. And so most of the times when you run this on a computer, most modern computers, the computer at some point will be smart enough to say, hey, I think you have an infinite loop here, or hey, I think you meant to stop this loop. But the point of it is just that this line of code, this while loop, will run forever. And so it's really important whenever you write whenever you create a while loop, or any loop for that matter, to make sure that eventually the conditional expression becomes false, right? This looks like the first example that we had done, except now I took out the count minus minus, right? Count is still equal to 3 at the beginning. On line 4, when I check count, is 3 greater than or equal to 1? Yes, it is. And on line 5, I console log out count as 3. Well, now I no longer change count, so when I go back to line 4 and I check the count value again, count is still going to be 3. 3 is still going to be greater than or equal to 1, so then I still run line 5. And I go back and check line 4 again, I run line 5, I check line 4, I run line 5, and that goes on indefinitely, right? So even though we have count stored in a variable, it doesn't matter because the conditional value will never become false, and therefore this while loop will continue on forever. Are there any questions on while loops before I move on to for loops? You're good? All right. Cool. Jaden, Irina, everything good? Cool. Perfect. All right, so then we'll move on to for loop. And just kind of as a matter of practicality, while loops are somewhat dangerous because there is this idea that maybe sometimes it just runs on forever. You'll see for loops a lot more commonly than you'll see while loops. So a while loop, a for loop. A for loop still requires 3 elements. Just like how the while loop required a while keyword, a for loop requires a for keyword. It takes in 3 optional expressions, so I guess we're cheating a little bit here and saying it requires 3 elements. And then the third thing is, once again, the block of code. The way that the for loop is set up is we still have our for keyword, but now in our parentheses, we actually have 3 things instead of just 1 thing. And then we have our block of code. And the way that the block of code runs is that, or the way that the for loop runs is that the block of code will keep running as long as the condition is true. And so on line 6 there, if you notice, in the for loop, in between the parentheses, we have 3 things. We have the initialization, followed by a semicolon, followed by a condition, followed by a semicolon, followed by something called the final expression. And so if we take a look at the example, the initialization is going to run once, and it's going to run first. And basically, that's going to be the counter that the loop is going to use. What's a counter? A counter usually is the variable that keeps track of a value in your for loop that usually, it doesn't have to, but in most cases it will keep track of how many times your for loop has ran and how many more times it's going to run. Okay, and then followed by the initialization, what we have is a condition. The condition here is just like the condition we saw in the while loop. The condition is a statement that will eventually evaluate either true or false. If it's true, then the loop will run again. If it's false, then we say, great, the for loop is now over. Let's move on to the next block of code. And then after each time we run this code, the final expression is run. The final expression usually is something that will update the counter variable. That will make sure that the counter variable eventually gets to a condition, and the counter variable will eventually reach a value that will make the condition false. So that was a lot of verb. Let's take a look at a loop. It probably makes it a little bit easier. On line 9, I have my for keyword, so I know I'm dealing with a for loop here. In between the parentheses, in the first part, I create a variable called I, and I set it equal to 1. In my condition, I check, is I less than or equal to 3? In my third and final expression part, I do I++, which means just add 1 to I. And then in my block of code, all I do is I console log out I is, and then the value of I. And when I run this code, the first time I run it, what the for loop does is it says, okay, great, let me create a variable called I, and give it the value of 1. And then let me check, is I less than or equal to 3? In this case, I is 1, so 1 is less than 3, so that's true. And that means I now move on to my block of code. I move on to line 10, and I console log out I is 1. After I console log out I is 1, I then move back to my final expression, the I++ part, and I add 1 to I. And that's the first iteration of my for loop. Well, how do I check if I should run again? Well, I check my condition again, right? I check I is less than or equal to 3 again. Is that statement still true? Well, I used to be 1, but now it's 2 because I added 1 to it at the end of the last iteration. So is 2 less than or equal to 3? And the answer is that's a true statement. 2 is less than 3. And so because that's true, I run line 10 again. I console log out I is 2, and then I go to I++. I add 1 more to I. So now I is 3. I go to my condition again, I check, is I less than or equal to 3? So is 3 less than or equal to 3? And the answer is yes, it's equal to 3, so that statement is still true. I then go to line 10, I console log out I is 3, and then I add 1 to I again, so now I is 4. At this point, I check my condition one more time and I say, is I less than or equal to 3? i.e. is 4 less than or equal to 3? And the answer is no, 4 is greater than 3. At that point, I know the condition is going to be false, and therefore I can say my for loop is now over and I can stop running it. Okay, so at the end of this, I've printed out I is 1, followed by I is 2, followed by I is 3, and then I'm finished with the function. Or sorry, I'm finished with the for loop. Does that make sense to folks? Any questions? That's good. Cool. Well, so then if we know kind of the mechanics of how for loops works in, right, then we realize that there's actually there's nothing in the for loop that says we have to keep adding 1 to a number, right? In this case, on my for loop, on line 2 there, right, I've created I, it was initial value of 5, and I say while I is greater than or equal to 1, and then for every iteration of I do I minus minus, so I subtract 1 from I. And so when I do run this loop, it will print out I is 5, followed by I is 4, 3, 2, 1, and then eventually when I reaches 0, my middle condition there, I is greater than or equal to 1, 0 is not greater than or equal to 1. At that point, that condition will fail, and my for loop will be done as well, right? And so this is all just to say that, like, in the previous example, we kept adding 1 to I. Here we can subtract 1 from I as well. But we also don't need to just add or subtract by 1, right? We can increment by any number. Here, it's the same exact code as before, except now I start I at 100, and I check to make sure I is less than or equal to 300, and every iteration I add 100 to I instead of just 1. And that's totally fine. Once again, the for loop doesn't care how much you add or subtract. It just matters that you create a variable, you make a comparison, and then you update that variable to make sure that eventually the comparison or the conditional statement is going to become false. And so for loop is actually a really useful tool for going through a string. A string to us is like it's a bunch of words, but really you can think of it as just a collection or a list of characters, right? Here in my for loop, in the first part, I said let I equal 0, so I'm creating a new variable called I is equal to 0. My check is while I, the I value is less than letters dot length. Well, letters is the variable I create on line 2. That's just the characters A, B, C, D, E, F, G. And so letters.length says there are 7 characters in that string, right? So letters.length is 7. And then after every iteration, I add 1 to I. Well, why do I need I for in this case? On line 5, what I'm saying is, or on line 5, I basically create a variable called current letter. And the value of current letter is going to be equal to the letters string on line 2. And we're saying, hey, access that letter string and access it at the position of I, at the index of I. Well, I starts at 0, and so the first time we access it, we're going to be starting over at the first letter in the letter string. Once we do that, we're going to console log out the current letter, and then when that's finished, our for loop goes back to line 4 and adds 1 to I. So now I is going to be 1. Well, 1 is still less than letters.length, which is 7. And so then we go to line 5 again. We recreate another variable called current letter, and we set the value equal to the letters index of 1 now. So now we're looking at the second letter of the letter string, and then we console log it out. And we do this over and over again all the way until we get to the very end, in which case I is equal to 6, right? So letters index 6 gives me the last letter, which is G. I console log out G, and then I plus plus is going to give me add 1 to this 6, so it's going to be 7, and then I check my conditional statement. Is I less than letters.length? Is 7 less than 7? And the answer is no, it's not less than, it's equal to. And so at that point, my for loop ends, right? So all of these slides are available to you through the full stack platform. And this is what I would kind of bookmark for you to look through. This is a pretty good example of kind of how to use a for loop to go through, or we call traverse or iterate through a string, right? Every character in the string has a position, right? 0 through 6. And so therefore, if we create an I that starts at 0 and we add 1 to it every time, eventually it will reach 6. and for every number that it crosses through, we can just get the character at that position in the string, right? So we get the character A at position 0, we get the letter B at position 1, we get the letter C at position 2, and so on and so forth. Everyone's good there? Cool. So then the last two things we'll talk about on the loop side of it are two keywords. Once again, they're keywords, which means that they cannot be used as variable names in JavaScript. It also means that when you write it, they'll show us different colors. There's the continue keyword, and all that the continue keyword does is continue allows you to skip the rest of this loop, but it allows you to keep moving to the next iteration. And so what does that mean? Here I have a for loop that says let I equals 1, while I is less than or equal to 5. I'm going to run this block of code, and then after the loop is over, I'll do I++. And so the first time we run this code, I is equal to 1, 1 is less than equal to 5, and then we run this code. On line 3, it checks if I is equal to 3 or not. Well, I is 1, so it's not equal to 3. So we skip lines, so we skip lines 4, 5, and 6, and we will move on to line 7, and we print out I is 1. After that, I++ makes I equal to 2, and now we say is 2 less than or equal to 5. And we go to the block of code again, or sorry, 2 is less than or equal to 5, so then we go to the block of code again. On line 3, we check, is 2 equal to 3? No, it's not, so we skip lines 4, 5, and 6, and we go to line 7. I is now 2. Then we go on and we do add one more to I, so now I is 3, and we say, is 3 less than or equal to 5? And then we go into, and yes it is, so then we go to our block of code, we go to line 3. If I is equal to 3, which it is, we then hit continue. And all continue does at that point is it allows us to skip lines 5, 6, and 7, and then go on straight into the final expression, as in it goes back to the I++, where I now becomes 4, right? Because we do 3++, so that's 4. And then we check, is 4 less than or equal to 5? And the answer is yes, it is less than 5. On line 3, we check, is 4 equal to 3? No, it's not, so we skip lines 4, 5, and 6, and we print out I as 4. And we do this for 5 as well. And so effectively, all we've really done is, if you look at our code and kind of take a step backwards, all we're really saying is, when I is equal to 3, let's hit continue. What continue does is continue on line 4 allows you to skip lines 5, 6, and 7, but it still moves you on to the next iteration of the loop. And so when we look at the printout, all we've really done is print out 1, 2, we've skipped 3, but then we also print out 4 and 5. Okay, that's all this is saying. Right, so continue allows you to skip this iteration allows you to skip the rest of this iteration of the loop, but it allows you to move on, or it moves you on to the next iteration. Then the continue keyword also works in while loops as well, right? Whenever you see a continue keyword, all that means is don't read the rest of this iteration, move on to the next iteration, right? Move on to the next conditional statement. Here is the same exact idea, except look where the continue is located. It's located on line 7. And so what line 10 does is line 10 says it prints out the value of count, and then it decrease, and then on line 11 we decrease count by 1. If you look at the if statement there on line 5 through 8, on line 5 we're saying if the remainder of count when we divide it by 2 is 0, aka if count is even. On line 6 we still decrease count by 1, but then we hit continue, which means we skip lines 8, 9, 10, and 11. And effectively what that means is on line 5 is what line 5 is saying is if the number count is even, well then skip lines 8, 9, 10, and 11, which basically means don't print out the value of count. And so paraphrase that another way, all that is telling you is, hey, only print out the odd numbers. Okay, so once again, all continue does is saying is don't read the rest of this iteration, move on to the next iteration, move on to the next turn in the loop. We can then contrast that with our break keyword, and you can think of break keyword as almost like an emergency break glass in case of an emergency card. What the break keyword does is it says just finish this entire loop right now, like finish this iteration, but also skip all the future iterations too. And so here on line 4, I'm my while loop, and in my while loop, I've created a cardinal sin of having my condition always be true. On line 5, I have a variable called, or migrate, I created on line 2 initially, and all I did on line 5 is I've added the string plus to it. And on line 7, what I do is I check to see if that string of the length is equal to 3. If it is, I hit the break keyword, right? And so on the surface, it looks kind of almost like, well, if I keep running this forever, well, this loop will run forever because the condition on line 4 will never be false. But I see on line 8 there that there is a break in there, and I reach that break on if line 7 becomes true, which is if migrate.length becomes 3. And so what this says is I'm going to keep adding pluses to my string A until I get to a point in which the length of migrate is equal to 3, so that's A++, at which point I will hit the break keyword, and I will just finish up with this loop entirely, right? There is no next iteration. I'm just completely done with this loop. And this also works for for loops as well. At my for loop here, where I start with I equals 10, I say while I is greater than or equal to 1, I decrease I by 1 each and every time. Here, on line 3, I console log out the value of I. On line 5, I have a check. If I is equal to 7, I'm done with the loop. And so when I run this loop, I do I is 10, 9, 8, 7. And then once I hit 7, I hit the break keyword, and that means the rest of my loop is also skipped over, and I move on to lines 9 and 10. So the break keyword just lets you break out of the entire loop altogether. Okay. Any questions on loops before we move on to the debugging side? Awesome. Cool. Awesome. Okay, so the debugging side, like I said, I won't spend too much time on because it is more of an art than a science, and it's something that you'll pick up as you do more and more. Just note that debugging is normal, and developers spend way more time debugging code than writing it, like on a magnitude more. Right? Code very rarely works on the first try, which is something that you will find out very shortly. Um, in the coding environment that we're going to have you use, there's basically a few ways to think about the way that the results are interpreted. The first one is please read the when a test fails, please read the error. Okay. If you look on the right hand side of the image at the screenshot here, you'll notice on the gray text in the middle there, there's something called reference error. Sum is not defined. But not only does it not have that, not only does it have that tells you what the error is, beneath it, notice how it also has 3 lines. One is called add only odds, the next one is called add object.it, and the third one is called add attempt sync. What that is that's called a stack trace. Essentially, that tells you not only what the error is, but which lines of code the computer ran in order to get to that error. Effectively, it helps you kind of retrace the computer steps and understand what did it do to get to the error that you saw. The way that the stack trace is laid out is that the most recent line is on top. And so in this case, once we got the error, the last line that ran was at only odds. Or the latest line that ran was only odds. The latest line that ran before only odds was at object.it, and then the line before that was at attempt sync. And so that tells you not only just what the error was, but how it was caused. And then if we look at only odds there, notice how on the right hand side we have the at localhost :7357. But then after that tells you where the computer is. But then after that, notice how we also have a file called onlyodds.js, and then we have a colon followed by 2 numbers. Well, those 2 numbers are actually very useful for us too, because those 2 numbers tell us the line number. The first number tells us a line, and the second number tells us the character where the error occurred. Okay. Usually we don't need the character, the line is more than sufficient. And the only other thing I'll say here is just that sometimes where the error is being caused is not where we see the error kind of manifest itself. The analogy that I always give is if there's a car accident and the airbag doesn't work, well, it doesn't mean that the airbag was broken at the point of the crash, right? The airbag was actually broken during the manufacturing process, but we only saw the effects during the crash. That's kind of the way a stack trace works too, right? Is that it doesn't necessarily guarantee you that's where the error occurred, but it at least allows you to see, kind of like allows you to see what was the last thing that happened before the error got triggered. And so it's up to you to understand not just what the error is and know what line number it was triggered by, but then to work backwards from there and try to understand what caused the error in the first place. There are there are main two types of errors that we're going to cover here. You'll see a lot more when you do the workshop. The first one is called reference error. This basically means you try using a variable that doesn't exist. Sometimes this happens because of scope, which we'll talk about on Thursday. More often than not, this just means you try to use a variable that you misspelled. Right? It sounds silly, but it's very, very true, and it's the most common reason why we see reference errors in the beginning in beginner programmers. Yep, and this is what I said with the stack trace. The other reason why tests might fail is because the test expects your function to do something, and your test runs. It's just giving you the wrong answer, which means there's something logically wrong with your code. And so when we look at tests that fail, also take a look at the explanation for why the test failed, not just that it failed. And then last but not least, be very careful with returns versus console logs. Remember, console logs are just for human consumption. They help the user see the code. Computers don't care about console logs. If you want your test to give back if you want your function to give back a value, always use return. Okay, and so if you ever see any errors around, oh, I got undefined, but I expect it to be something else, that just means, hey, I got in your function, you didn't return anything to me, and therefore by default the function will return undefined, and theoretically I should be expecting something that's not undefined. And then last but not least, and I'll walk you through an example of the code once we get started here. Just note that in the code pen, it should be very clear where we want you to write your code. But also note that we actually put the test on the bottom as well for you. So if at any point the tests aren't running, you can take a look to see how we're executing the tests and try to recreate the errors on your side. Yep. Okay. So like I said, today was mostly on loops. We talked about the while loop and the for loop. We talked a little bit about the break and continue keywords. And then we did a few pages on debugging. But once again, that's something that you'll get a lot more intimate experiences once you start writing the code. Now, one of the other things I wanted to walk through actually was this idea that yesterday when you guys did the workshop,